The topic of this video is graphing inequalities, specifically linear inequalities in the Cartesian plane. Let's look at a problem. Graph the system of linear inequalities. Tell whether the graph is bounded or unbounded and label the corner points. Okay, so you can see that we have 5 inequality statements in this one problem, but don't let that scare you. The top 2 inequalities are just telling us what quadrant we're going to draw all of our lines and points in. Let's get very specific and look at that for just a moment. You might recall that in a Cartesian coordinate grid, in the upper right-hand corner we have quadrant 1, and then we proceed counterclockwise with our numbering all the way around. One of the characteristics of quadrant 1 is that all of the coordinates are positive. The x's are positive and the y's are positive. One of the characteristics of quadrant 2 is that the x's are negative, but the y's are positive. One of the characteristics of quadrant 3 is that both coordinates are negative. And in quadrant 4, the x's are positive, but the y's are negative. Each one of these positive and negative labels can be written as an inequality. For example, this is telling me the x's are positive, so I could say x is greater than or equal to 0. And this is telling me that the y's are positive, so I could say y is greater than or equal to 0. Technically, with quadrants, we don't include the points that are sitting on the axes, but I'm writing this here so that we have a sense of connection to the problem that we're solving right now. I could write similar inequalities for my other quadrants. X is less than or equal to 0, y is greater than or equal to 0, x is less than or equal to 0, y is less than or equal to 0, x is greater than or equal to 0, y is less than or equal to 0. So you can see that our first 2 inequalities in our system are simply telling us which one of the 4 quadrants we're dealing with in this problem. We're dealing with quadrant 1. So when we go ahead and create our lines, it's actually very easy. X greater than or equal to 0 is a vertical line, which is the y-axis. And because it says greater than, we shade to the right. So I'm going to box in my graph, and we're going to shade to the right. And with our second inequality, y is greater than or equal to 0, I'm going to put my line on top of the x-axis. And then I'm going to shade up because it says y is greater than or equal to. Got a little carried away here. I'm supposed to be shading up from the x-axis. Let me get rid of these. Up from the x-axis. Okay, so you can see that using our first 2 inequalities, the parts of the graph where the red and orange shading are located is in the quadrant 1 of our graph. So when you see something like this, just keep in mind that this is telling you what quadrant that you are dealing with. No big deal. All right, so now we're going to move on to our other inequalities, inequalities 3, 4, and 5. Let's start with inequality 3. So I have x plus y is greater than or equal to 2. I'm going to solve this for y. Moving the x to the other side and changing its sign gives me y is greater than or equal to negative x plus 2. Remember, this negative is actually the number negative 1. So I could write this as negative 1 over 1 x plus 2 if I wanted to. And then I can graph this using the slope-intercept method. First, I'm going to graph my y-intercept of 2, which is here. And then I'm going to use my slope of negative 1 over 1 to rise and run to find other points on my line. Down 1, right 1. So that would be this point here and this point here. And I would draw my solid line through those points. And once I have that, then I would shade up. Up because it says y, so my only two choices are up or down, and up specifically because it says greater than or equal to. So I would shade up from this line. Now, one of the characteristics of a problem like this one is that when you have 5 different colors on the same graph grid, it can be a bit difficult to identify your final shaded region when you are done. It can be difficult to find the part of the graph where you have red and orange and light blue and dark blue and green all in the same place. In anticipation of this future problem, I'm going to do something a little bit special here on this particular problem. So far we've created 3 shaded regions. What I'm going to do is I'm going to write the word no adjacent to each of the lines that we've shaded near so far. The word no indicates that this is not the side that would be in our solution region. So for example, with this vertical red line, we shaded to the right of it, which means we do not want the part to the left. So I'm going to write no right next to that line. And with the orange line, we said that we wanted to shade up, which means we don't want the part that's underneath it. So I'm just going to write no underneath it. And with this light blue line, we shaded up, which means we don't want the part over here. So I'm going to write no there. And we're going to continue this for each of our other lines. So let's now move on to inequality 4. All right, so inequality 4 says x plus 2y is less than or equal to 10. Moving the x to the other side, we have 2y is less than or equal to negative x plus 10. Dividing both sides by 2, and recognizing that the coefficient of negative x is actually negative 1, this gives us the statement y is less than or equal to negative 1 half x plus 10 over 2, which is 5. All right, let's go ahead and graph this particular line using our solid blue line. So y-intercept is 5, which we can see here. The slope is rise over run, negative 1 over positive 2. So from here, we're going to go down 1 and 2 to the right. You'll notice that I've drawn little black dots here. This is going to help us to keep our work clean and readable. So down 1 and 2 to the right would be here. Down 1 and 2 to the right would be here. Down 1 and 2 to the right would be here. Down 1 and 2 to the right would be here. Down 1 and 2 to the right would be here. And it looks like we're going to hit the x-axis at 10. It's a solid line because the inequality says less than or equal to. And so we're going to go ahead and draw a solid line connecting all of these dots. All right, how about the shading? Well, it says y, so my only 2 choices are up or down, and it says less than or equal to, so I'm going to shade down. So from the blue, dark blue line that I just drew, I'm now going to shade down. Okay, and in keeping with the no convention that I established before, if we are shading down, that means we do not want anything that's up here. So I'm just going to write no, 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 no all the way across, indicating that we do not want anything over here. All right, and that brings us to our final inequality, inequality number 5. Inequality number 5 says 2x plus y is less than or equal to 10. I'll move the 2x to the other side where it becomes negative. So then I have y is less than or equal to negative 2x plus 10. This is already in the slope-intercept form, so I'll plot my y-intercept of 10. I can write negative 2 as the fraction negative 2 over 1 so that I can see my rise over my run. So this is 2 down and 1 to the right. Again, look at the black dots in the background, and that is going to help you with this particular problem with the graphing. So 2 down, 1, 2, and 1 to the right. 2 down 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 and 1 to the right, and it looks like we're hitting the x-axis at 5. It's again a solid line type. In fact, every line in this problem is a solid line type because every inequality has the or equal to component. And so I will draw a solid line through all 5 of these points. Oops, looks like I've got 6 points, all 6 of these points. Okay, great. Where do I shade? It looks like I'm shading down. Y, so it's either up or down, less than, so it's down. So from this green, I'm going to shade down. You can see how very difficult it would be right now to identify what part of my graph has all 5 colors. This is a hot mess if I've ever seen one. Okay, and using our no convention, if we were shading down, that means no, we don't want anything above the line. So I'm just going to put no, 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 no for everything above the line. Okay, great. So we have now graphed all 5 of our inequalities individually. We're ready to find the overlap of the shaded region. Well, one of the big advantages of the no method that I'm using here is that it actually ends up surrounding our solution method. You can see that the word no sort of forms a bit of a circle here. It's actually a 5-sided shape, a pentagon. And this is actually our solution region. This is the part where we can see that we have red, and we have orange, and we have light blue, and we have dark blue, and we have green. So by using the no method, we are actually able to more easily identify the part of our graph that has all 5 colors in it. So I'm going to go ahead and shade this in. This is our solution region. And when you are entering this in your software application, this is the spot where you want to color in to create your final answer. Okay, so we have now graphed the system of linear inequalities. The only thing left to do is to determine if it is bounded or unbounded and label the corner points. So we'll go ahead and identify that this is bounded because it's so easy to do. This is not going to infinity in any particular direction. If I wanted to, I could draw a circle all the way around my solution region and therefore identify that this is a bounded system. But when it comes to the corner points, we want to clean up our graph just a little bit, and I'm going to help us identify those corner points in our next video, which will continue the solution to this problem.